Hi guys, today we're starting a new topic and it's called stoichiometry. Stoichiometry is a part of chemistry that is going to deal with the law of the conservation of mass, which tells you that atoms are not created and they're not destroyed. If you have a chemical reaction, they are just transformed. So stoichiometry deals with the amount of substances that are involved in a chemical reaction, and it measures the elements and its transformation. For example, if we have a chemical reaction, here it's the number of moles or the number we put in balancing. Remember, we put a number in there. A given amount of A substance plus given amount of B substance equals to given amount of C and given amount of D. That's going to give us the moles. So when we're talking about stoichiometry, this means that if I have here a sodium and in here chloride, I can tell what amount of sodium chloride I'm going to form at the end, just to give you an idea of what we're going to do. And this is the reason why we needed to have clear that the conversions of moles to grams and grams to moles, because when we're talking about stoichiometry, we can go from mole A to mole B, or to mole C or mole D. We can go from mole A to grams. We can also go from gram to mole, or from gram to gram. All right. Right now, probably you're not understanding what I'm saying, so I'm gonna make an example. We can go from gram to gram. All right, but if you're asking to transform something from mole to gram, well, we just make that conversion, all right? We're not creating or destroying anything, we're just converting. So I'm going to give you an example of what is a stoichiometry with a chemical reaction, so that you understand that a little bit better. All right, so we have an example. SO2 reacts with O2 to form SO3. So we have our chemical reaction. SO2 plus O2 equals to, 2 SO3. All right, so step one, I'm going to balance. S and O. 1, 4, 1, 3. How am I going to make this? I'm going to put a 2 here. 2, 4, 6. I'm going to put a 2 here. 2 times 3, 6. All right, balanced. I did it quickly because we already know how to balance. And if you don't, well, just give me a call and I'll explain. All right? Okay, so we already have it balanced. And this exercise is telling me that if I have 3.4 moles, of SO2, how many moles of SO3 am I going to produce? How many of this am I going to produce? If I have 3.4. So we're going to convert. All right, these numbers are very important in stoichiometry. So I have 3.4 moles of SO2. I want to eliminate moles of SO2, so I put moles down of SO2. How many moles do I have of SO2? I have 2 moles. So I have 2 moles. And how many moles of SO3 do I have? I have 2 moles of SO3. So in this case, 3.4 moles of SO2 is going to produce 3.4 moles of SO3. All right. But let's make a different example, because this one gave me the exact same answer. So I'm going to make a different example with the same exercise. Let's figure that we have 4.7 moles of SO2. how many oxygens do I need to react to produce SO3? So I'm going to figure that out. I have 4.7 moles of SO2 times, I have 2 moles of SO2 and only 1 mole of oxygen, of O2. So this is going to give me 2.35 mole of oxygen. Alright, so for me to make this reaction, I need 4.7 moles of SO2 and 2.35 moles of oxygen in order to produce SO3. Alright, so this is a simple example of this. You see, I do have another one to just see another example. So I'm going to make it another example. This is in your books, by the way, on page 233. There you can see the theory and one example that's on the book. I didn't grab the example on the book, so you can check it out if you want. Aluminum oxide plus iron. All right, let's balance. I have 2 irons, I have 1 iron, I'm gonna put a 2 here, 2 irons and 2 irons. 3 oxygens, 3 oxygens, 2 aluminums, 1 aluminum, I just put a 2 here. All right, so this exercise is telling me that I have 85 grams of iron oxide. How many moles of aluminum do I need in order for this reaction to happen? But check the question, it's asking me for moles. Alright, so this one's a little bit more complicated than the last one, but because when it's grams to grams, it's really easy, and moles to moles, it's really easy. But when we have it combined, it gets a little bit harder. So let's start. 85 grams of Fe2O3. How do I eliminate grams and pass it to moles? Do you guys remember? Grams of Fe2O3 equal to 1 mole of Fe2O3. All right. I want to eliminate grams, so I need the molar mass of this. So we already know that iron weighs 56 times 2 plus 3 times 16. Okay, and that's going to give me the molar mass of iron oxide, which is 160 grams. So, well, now I can eliminate grams, and I'm left with moles. And I want to convert to moles of aluminum. So I'm going to eliminate moles here. 1, because I don't have a number here, equals to how many moles of aluminum? 2. So I have 2 moles of aluminum here. And that's it. All right, I have 85 divided on 160 times 2. And your answer is 1.06 moles of aluminum. All right, so this is a stoichiometry. It becomes a little bit more complex because it's like taking everything that we learn right now all together. So it's a little bit more complicated. But once you get it, it's really easy. Plus, we're going to have a virtual class of this. Try to, all of you, try to be present on that class because we're going to be discussing this. Check your books, page 233. It has one example, and if not, well, I'm gonna keep you uploading videos. Don't worry, all right? I'm gonna explain the topic. If you don't understand, just text me. There's no need for you to be looking at different YouTube videos or etc. You just need to text me, all right? Have a nice day, guys.